Hey, what's up, everybody? It's your boy Algebra, aka Mr. Somerville, live coming to you direct from the studio. Happens to be my living room right now. Erica's not home from work yet, so I get to talk as much as I want to, and she won't get mad at me for telling corny jokes. Here we go. Today we're solving linear equations, but I'm going to put a little twist into it so we can connect it to what we've been working on, what you had your quiz over last week and what you had your test over earlier this week. Everything's going to blend together today, and hopefully by the end of it, you have a pretty good understanding of how to solve, how to graph, how to create, and do everything with the linear equation that we're going to need to be able to do this year. Having said all that, I've got two example problems for you right now. We're going to go ahead and get started right away with them. I've got 6 equals 3 over 4x plus 9. Before I actually get started solving anything, I want you to notice right now that this looks like a linear equation to me. Back when we first started talking about making equations, we said they always have x to the first power in them. But what's missing right now is the fact that it doesn't say y. This would be a y equals mx plus b equation, but there's something missing. I've replaced this letter y with a 6. And that's completely okay for me to do that. Because what I'm telling you when I ask you to solve an equation is I'm giving you the y value and asking you to go backwards, go and figure out how it showed up. I want to still create a t-chart, but I'm telling you what's going to be on the y side. You need to tell me what's on the x side. And so rather than writing out the t-chart, rather than graphing the line and trying to chase and trace backwards, what we're going to do is we're going to solve this equation instead. Yesterday we talked about it. We said that you should follow the saddest Meg that you know. Just like Meg on Family Guy, she's always sad. We want to get rid of subtraction and addition first. So I'm going to do minus 9, not just on one side, but both sides. Now that I have subtracted this 9, I don't like fractions. Nobody in this room really likes dealing with fractions. Therefore, let's get rid of that fraction. How do you get rid of divided by 4? Yeah, you're supposed to multiply by 4. So I'm going to do times 4 on both sides of the equation. As long as I do it on both sides, I'm not really changing anything. I'm just making it look a little bit different. All the values and all the relationships are still here. But because I'm reorganizing it, I'm manipulating it a little bit, it's getting me to a point where I have isolated this x value. The last step for me is to divide by the 3. I get negative 4 equals my x. So what this really tells me is that in the equation of y equals 3/4 x plus 9, there is such a point called negative 4, positive 6. That is a value that will show up on my t-chart. It's a relationship that says whenever I put in a negative 4, I will get out a 6. It tells me that when I plug in a negative 4 into the function, I get out a positive 6 as its value. All of these things are working together. We're creating a relationship that has a slope, it has a y-intercept. In this particular case, that would be 9. We could have used a different starting point for this equation. It could have been negative 4 comma 6. And so if I don't give you slope-intercept form, I might give you point slope. And in that case, we're looking at example number 2. I'm going to pause for a second, let everybody get onto the same page, and then we're going to be starting to work on example number 2. This example begins with point slope form. If you remember point slope form, it says that we have a slope still, but my point has been embedded into the formula itself. First thing first, if you remember our t-charts from before, We're saying that the starting point for this graph, the starting point for this t-chart would have been 4, -2, because I cancel out the 4 and I keep the +2. So knowing that information, you can tell that this is going to be a straight line. It has a slope of up 1 and over 2, but I'm telling you what the y value is. And since I'm telling you what the y value is, I want you to figure out how to get the x. Last time we talked about the saddest Meg we knew, the one from Family Guy. So we're still going to treat these problems the exact same way. I don't want you to deal with any of the grouping symbols. That parentheses doesn't matter to me right now because I need to get rid of addition and subtraction first. I'm going to do -2 on both sides. So somebody in the crowd is probably like, but I thought it was PEMDAS. How come you have it backwards? Remember, since we're using the opposites to cancel things out, we should use the opposite order as well. Sad Meg tells us to get rid of addition and subtraction first and work our way towards this parentheses. For those parents in the crowd, we changed it from being parentheses yesterday to talk about grouping symbols instead, because down the road we're going to talk about a lot of different types of symbols, and we might as well change it and get familiar early on in the school year. My final answer for this problem is that 10 equals my x value. So just a quick reminder, that not only tells me that I have 10 as the x value, it tells me that this is a correspondence between 10 and 5. It says that there's a point on my graph called 10, 5. Because all I did in the very beginning of the problem was trade out the y value for that 5, and this is our linear equation this time. Okay, so as I prepare the next couple examples, what I want to think about now is, what do I really mean when I say these are representations of functions? Earlier this school year, we said a function is a relationship between inputs and outputs in which a single input can only produce one particular output. So if I keep putting brownie mix into the oven, I have to get brownies out every time. I can't mysteriously show up with a batch of cookies. It doesn't work like that. You put something in, you're going to get the same thing out of this function. So let's talk about a function, f of x. And we're going to start off pretty simple. Let's go with 2 times x plus 7 on the inside minus 3 on the outside. What you know about this function is that it has a starting point. It has a constant slope where the change in y is going to be reflected in the change in x, where that's going up 2 and over 1, where the rise is 2 and the run is 1. This particular function is a straight line, and it can be represented not only by this formula, but also as a t-chart. This particular t-chart would start with a -7 and a -3. Why -7? Because you have to cancel out the parentheses. I know in the class right now there's some faces that say, yeah, I know how to do this. I know what's going on. And then you start filling in the t-chart because the confidence has built up. The confidence is brewing. You tell me that it's supposed to be a -6, -1. And then you tell me that it's supposed to be a -5, +1, because the slope says up 2 on the y side and up 1 on the x side. So why do I bring up how to make a t-chart again when we've been doing that for multiple weeks now? Well, I bring it up because what happens if I trade out part of that f of x and ask you for f of 13. There's no way you're going to tell me that you could keep on adding this T-chart, keep on going down the page. You can get to 13, no problem. You have established a pattern, but that sounds like a whole lot of work, a whole lot of writing, and a lot of wasted space on top of that. So there should be a way to figure out what you get for the f of 13 based on that formula. And that is to take the 13, plug it in for the x, and see what happens when you start to simplify. F of 13 is going to come from 2 times 20 minus 3. You're going to get 40 minus 3. Your final answer for the f of 13 is that you have a point on the graph called 13, 37. Okay, pause, time out for a second. Hold up, Miss Somerville. That makes perfect sense. That's how we started making T-charts in the very first place a long time ago. Well, what happens then in your infinite wisdom, Amir? What is it going to say if I ask you about 41 being the y value? So you've been figuring out the y. You've been able to plug in an x variable and go and figure out the y. But how do you deal with it if I tell you what y is and ask you to figure out where it came from? What if I start at the answer and ask you to go back to the beginning of the question? How do you deal with that? Well, the answer is you put the 41 in for the y and you keep the x. This problem looks exactly like the ones we started with at the top of the page now. It tells me that I need to solve for x, and the saddest meg of all is going to help me do that. I'm going to add 3 to both sides. Boom, bam. 44 equals 2 times x plus 7. I can divide both sides by 2. When I divide it, I get 22 equals x plus 7. And I'll subtract the 7 just so I can get the x all by itself. My final answer is that 15 is what the x value is going to be if my y is 41. Okay, let me go ahead and ask you one more. What if I say something like, instead of a y, what if I said f of x equals 21? Like I did the voice there for a second. If I say that f of x equals 21, again, I'm just telling you what the y value is. It still says x in the function. That means I still don't know what x is. So how can I figure that out? What I'm going to do is I'm going to take the 21. I'm going to put it in where the y is and solve it for this x value. Using the same methodology, I'm going to add the 3 to both sides. I would get 2 times x plus 7 is 24. I divide both sides by 2. So now I have 12 equals x plus 7. Finally, subtract the 7 away. And this time I get a point that says x is 5 and its y value is 21. So what I've actually done is I've added more and more levels to the T-chart. I'm going farther and farther down the T-chart without actually writing it out. 2 additional points to this graph that I never actually put on there were 15, 41 and 5, 21. And if you remember when I told you the x was 13, you ended up with 37. So I have more than just 3 points on this line. I can go to 6. This concludes the first video. Please pause the screen and go to the next one. Thank you.